Hi all, welcome back to the video for multiple linear regressions. So let's not waste our time and get into it. Uh, so as usual, I'm going to start with the importation of library. If you have watched my earlier videos, this is not something new, so it should not be difficult. I'm going to read the data. So I have this uh, file uh, called read wage data wage uh, I'm sorry, wage data.csv, and header equal to 0, index column equal to 0. Let's inspect my df. So you see you have more variables, you have more columns for this data frame. First of all, I only need to look at these 5. This LH is going to be my explanatory variable. Female, age, education, and part time is going to be my explanatory variables. So I won't get into why I'm using LH instead of wage. That is not the main focus for this video. So let's not waste our time and get into the OLS regression. Okay, the dependent variable and explanatory variable. Before you in for single regressions, you read only one column, but now you are going to read multiple columns. That's the only difference. So female, age, and education, EDUC, and part time. Good. I need to add the constant to that explanatory variable, and then so now I can do OLS. What is the OLS is dependent variable regress on the explanatory variable. I call it OLS fit is OLS dot fit and OLS dot fit dot summary. Yeah, good. Uh, so now you have your regression equation. I have already written here, which is in number 4. Now uh let's let's think about this equation. So if you think about it, this equation is telling us that for education level, because your data frame, your data has education variable, and it has 4 values from 1 to 4, because education is divided into 4, is put into 4 bins. But what this equation telling us that the effects of wage rise from the increase in education level is always constant, regardless of whether you are jumping from education level 1 to 2, or from 2 to 3, or 3 to 4. Your increase in wage, or your increase in wage, is going to be the same. Of course, you think that could have been true. So you want to find out, you want to be more specific. So what do? Instead of using one variable for education, you are going to break it down into 3 more variables, which we which is the which is which is from these 3 columns: ed2, ed3, and ed4. If you have education level 1, all these 3 value will be 0. If you have education level 3, ed3 will be 1. Okay, so I want to do that. I don't think that this the first regression I did is quite precise, so I want to make it more precise. I want to find out more. So I will remove this education, and instead of this education, I am going to put ed1 and ed2 and ED3. Okay, I want to change maybe, oh yes, I need to change the name. So let's call it endo, and let's call it exo, and let's call it exo, and let's call this exo. Good. Oops, what is wrong here? I don't think anything is wrong here. ED1 not index, cannot be. Oh, sorry. Yeah, it should be ED2, ED3, and ED4. Awesome. And I will copy these two to save my time. And change this to endo, and change this to exo, and OLS ED. I call it OLS ED, OLS ED, OLS ED. Awesome. So now you have, instead of, you have ED2, ED3, and ED4 in place of education variable. And I have already written the equation here. So now if you look at that equation and you see that earlier your equation is saying that education increase should be the same for all types of increase, 1 to 2, 2 to 3, and 3 to 4. But now you see that then if that is true, the coefficient for ED3 should be 2 times the coefficient for ED2. Similarly, the coefficient for ED4 should be 3 times the coefficient for ED2. But you see, your equation is saying that is not the case. So you can state with probably more confidence that the effects on the wage difference of increase in one education level is not constant. But you need something more specific. You need to, in order to be able to state it with some level of confidence, you need to conduct your hypothesis test. So my hypothesis test is going to be this. Hypothesis test. Okay, it's still recording. I'm sorry. Hypothesis test is my null. Oops. Oh, it's all right. Hypothesis is that my B6 should be 2, B5. So what am I saying? I mean B6 is the sixth variable of the second regression. So I'm saying that ED3, the coefficient for ED3, which I call it B6, should be 2 times the B5, and B7 should be 3 times the B5. This is my null hypothesis. Of course, alternative hypothesis will be B6 is not equal to 2B5 and B7 is not equal to 3B5. Let me change to markdown. Okay, good. So how do I do that? You can do that with, you can use the equation with this F statistic equation, but I think that will waste time. So instead of doing that, let's go straight into using the existing library to do the F test. So you can do that with just one line here, but what you need is the matrix that's specifying the linear restriction you impose on the model. So what is this matrix? What is this A? What should my A matrix be to to impose these two linear restriction? Because you have two linear restriction. You are saying that B6 should be equal to 2B5 and B7 should be equal to 3B5. This is your null hypothesis. If my F test say otherwise, then I will reject the null hypothesis. So my A matrix should be I'm going to use numpy array. Let's see, I need 2 columns. So sorry, 2 rows. So you will ask me, why do I need 2 rows? Because I have 2 restrictions and I need 7 columns. 0 0 0, and let's copy all these. 0 0 0 and 0 0 0. But you will ask me, it can't be, right? My matrix cannot be all 0, right? Of course. So I'm going to change here. which I think is -2, and here will be 1, and here will be -3, and here will be 1. So you will ask me, how do I know that? Okay, so I already state that B6 is equal to 2B5, right? Which means -2B5 plus B6 is equal to 0. Similarly, B7 is equal to 3B5, which that means -3B B5 plus B7 equal to 0. So this -2 correspond to -2 here because this -2 is in the fifth column. So the fifth column correspond to the fifth variables ed2 here, and this one is of course from this 1b6. So this row is for the first restriction, linear restriction you have, and the second row, this one is for the second linear restriction you have. So -3 b5 plus b7 equal to 0. Okay, I hope you understand. If you have read your lecture notes on hypothesis testing, you should be able to understand. And with this A, I can do F test easily. So I'm going to print. I'm going to just copy this. But it's not result. It will be my OLS defeat. And let's see what I get. Oops. So your F statistic is 10.56. You can find out the F critical values to determine whether or not to reject the null hypothesis. But anyway, you can just look at p-value too. Since p-value is really small, you are going to reject the null hypothesis and accept the alternative, which is saying that the effects of increase in one education level is not constant. I have actually written some notes here too. If you are sticking to these uh, regressions, your effects of increase in one education level is constant, is always 26.26. So someone going from master level, level 3 to PhD level, level 4, same. Or it's the same as someone going from high school education level to bachelor level degree. But since it can be true, you break it down into you break down education into three more variables, ed2, ed3, and ed4, and you do the F test, and you find out that yeah, the effects of increase is not the same. You can also find out from how much from the equation, and you see that the increase the wage increase from level wage increase for someone who goes from level 3 to level 4 is much higher than someone who goes from level 1 to level 2. Okay, so I think this is all I have for now. In the next video, I'm going to delve deeper into things like AIC and BIC. Okay, so I hope you find this video useful, and please watch my future videos. Thank you so much.